I'm Joe Insley from Argonne National Lab, and I work with some collaborators at San Diego Supercomputing Center who've done some astrophysics simulations, and that's what we're looking at here is visualizations that I've done with them, where we compare the several variables from two different simulations, one with radiation hydrodynamics in it and one without, and we use VL3, which is a volume rendering application that we've written at Argonne and University of Chicago. And so we use that package to load the data in its native ENSO HDF5 format, pull it into our renderer. We have some capabilities in the renderer to do these variable comparisons, which, like I said, we're looking at the difference of these two variables. The volume was calculated on 3200 cubed unigrid volume. We're looking at a 1K cubed subset of that data right now. We can look at the whole thing, but when you look at the whole thing, it's very dense, so it's hard to see a lot of the details in it. So we chop that down to a subcube of it in order to be able to see some of the details in the inner structure.
Part of the visualization software has been developed at Argonne Laboratories. What is your contribution?
So my contribution has been a lot to do with some of the data movement in terms of reading the data off of disk.
How long does it need to create such a visualization?
So the actual rendering part, it can render it in real time. The 1K cube volume, it's a parallel renderer. This particular instance I was running on half a dozen nodes of our cluster, and it rendered it in real time, on the order of 20 frames a second or so. And then it took a lot of back and forth work with myself working with the scientists to figure out what it was we were looking for. And so that was an iterative, collaborative process. But once we actually came up with what we wanted to look like, rendered out the movie that we were seeing, took on the order of an hour to render I think it's about a 2-minute movie.
And who is the PI for the science part?
The PI for the science side is Mike Norman at San Diego Supercomputer Center. He and Robert Harkness and Rick Wagner are the three main collaborators I've worked with.
And how do you work in the collaboration? You are in different places. Do you meet? Is everything virtual?
Right, so a lot of it has been back and forth over the phone or Skype, talking with one another. Some of the last stuff that we did was, this is a different data set. We actually did via Skype, where I was interactive with the data, and I would take a snapshot and push it to a web page, and then Rick would look at it, and then we would discuss, oh, why don't we try doing this, make some changes, and then I'd shoot him another one. We have done some stuff where we've done streaming from our visualization cluster to their tile display wall, which is a demonstration that we've done with the same software. The last couple of years at SC, we've done streaming visualization with volume rendering using the same software and some dedicated network.
At Argonne, you are offering this service of visualization just to San Diego or to different research centers?
So the relationship with San Diego started a couple of years. It was a project that we were interested in doing. The streaming stuff is how it initiated, and it was a joint interest that we both had. But they're also an InSight project, which is the Department of Energy, the allocation process on the leadership computing facility resources. And so, because we're a leadership computing resource site, they did some of their calculations were actually done at the Oak Ridge, on the Oak Ridge computer, but they're InSight partners. So,
what does it mean, the streaming project? Can you tell more about that?
So the streaming project was, and it's an ongoing activity where the volume rendering can be streamed over the wide area. So as it's being rendered, there's one of the other components in this modular system. You can stream it out over the network to another component on the other end that is some tile display software that collects the multiple streams and then displays them on a tile display. And when we did this at supercomputing the last couple of years, there's also a web-based client that you can use to control it. So we were remotely controlling the visualization. So the visualization was happening on the cluster at Argonne, and then was streaming out over the wide area to a display cluster that was on the show floor in the San Diego booth. And then we had a web browser that enabled us to do remote control of that, send control messages back to the running visualization volume rendering on at the Argonne resource, and you could interactively control, change the transfer function and colors and change the view and so forth. So that was one of the first times that they were able to look at this data interactively over the wide area.
What is the bandwidth you are using?
In that case, we had a dedicated reservation of 10 gigabit reservation between over ESNet between Argonne and the show floor, and we utilized that full bandwidth. We did, in one instance, we streamed a 4K by 2K or thereabouts resolution, a single instance of that to their display wall, and then in other cases we were interested in exploring multiple variables at the same time, so we had multiple instances of the VL3 pipeline running at the same time, streaming, also filling that bandwidth, but with multiple streams using multiple control connections between the tile display software and the volume rendering software on the visualization side.
About this streaming, what are still the open point about research? Is the technology already mature to be used in every center, or is still in development?
It's somewhat still in development. We haven't. It's all open source, but we haven't distributed as such. We use an underlying library that was written by one of the local guys in our group as part of his PhD thesis called Solaritas, and it does streaming over TCP. It can use compressed, but we were streaming raw pixels over the wide area and recompiling them on the destination side.
Okay, Joe, thank you very much.
Thank you.